Identify the correct root locus from the figures given below, referring to poles as plus or minus j5 and zeros as plus or minus j10, respectively of g of s, h of s of a single closed loop control system. Among the options, which is the right answer? See, in this problem you have 10 and 5, and this is minus 5 and this is minus 10, and this is the point of interest, and if we move across the point of interest, this is minus 90 degrees and this is plus 90 degrees because it is moving in anti-clockwise direction. This is plus 90 degrees. We know angle of phi is equals to angle of zeros minus angle of poles. Angle of zeros is equals to this 0 and this 0. 90 minus 90 minus angle of poles, you will get it as minus 90. So overall you will get it as minus 90. We know angle of departure formula, that is 180 plus angle of phi, that is 180 minus 90. You will get it as 90. So 90 degrees. This will move in this direction, angle of departure, and this will move towards zeros in this direction. Among the options, none of the option matches, so none of these. Given g of s, h of s is k into s plus 10 whole square into s plus 100 divided by s into s plus 25. He is asking number of root loci terminating at infinity. Okay, here number of poles are 2, number of zeros are 3. So zeros are more than poles. Z minus p is equals to 1. So by mistake don't place answer as 1 because he is asking number of root loci terminating at infinity. So number of root loci terminating at infinity is 0 because here zeros are 3 and poles are 2. One pole is less than 0. So one pole is less than 0. So one root loci that will be originate at infinity, that will not terminate at infinity. One root loci is originate at infinity because z minus p is equals to 1. So answer is 0. Root locus of s into s plus 2 plus k by k into s plus 4 is equals to 0 is a circle. What are the coordinates of the center of circle? You can write it as 1 plus k into s plus 4 by s into s plus 2. G of s, h of s is equals to k into s in s plus b divided by s into s plus a. From this standard form, you can write center as minus b comma 0 and radius as under root b square minus ab. Loop transfer function of a unity feedback control system is given as g of s is equals to k into s square plus 64 divided by s into s square plus 16. He is asking to find the root locus diagram. Here the poles are at s is equals to 0 and s is equals to plus or minus j4, and zeros are equals to s is equals to plus or minus j8. See, here pole s is equals to 0 and zeros are at s is equals to plus or minus j8, and this is j8 and this is j8, and poles are at s is equals to plus or minus j4. Okay, this is j8, this is j4, and this is j4, and this is j8, and this is the point of interest. So I'll connect this to all the points. So by moving this 0 to the point of interest, you will get it as minus 90 degrees, and this moving to the point of interest, you will get it as plus 90 degrees, and this also anticlockwise plus 90 degrees, and this also plus 90 degrees. We know angle of phi is equals to angle of zeros minus angle of poles. Here angle of 0, first angle is minus 90 degrees and this second angle is plus 90 degrees, and minus poles, this is plus 90 plus 90, so plus 90 plus 90, so you will get it as overall as minus 180 degrees. We know angle of departure is equals to 180 plus 5, which is you will get it as 0 degrees, and root locus exists on the real axis where it has odd number of roots on the right side of the right side. So here you have 1 2 3 4 5. 5 is a odd number and root locus exists here, and it flows through the infinite because by default you have zeros at infinite. So root locus exists on this real axis where it has odd number of roots on the right of its plane, and you have here, you got here angle of departure as 0 degrees, so it will originate at pole and terminate at 0 degrees. Here also it will originate at pole and here it terminate at 0, here also at 0 degrees. So the angle between the two adjacent asymptotes in a root locus diagram is, we know angle of asymptote formula as 2q plus 1 into 180 degrees by p minus z. Now in this we will increase q by 1. So phi 1 you will take it as 2q plus 1 into 180 degrees by p minus z. Next phi 2 you will take it as 2 into q plus 1 into 180 degrees by p minus z. By having the difference between the two angles, you will get answer as 360 degrees by p minus z. So the angle between the two adjacent asymptotes in a root locus diagram is 360 degrees by p minus z. In this statement, he has given the network function n of s is denoted by with scale factor multiplied with ratio of zero factors with pole factors. That is the right statement. In statement 2, where there are n zeros and m poles, then poles at infinite are multiplicity or degree of n minus n. Similarly, when n is less than m, the zeros at infinity are multiplicity or degree of m minus n. In this, both statements are correct, but they are not interlinked to each other. They are independently correct. From above statements, you must keep in mind that always poles and zeros must be equal. In case if poles are greater than zeros, then p minus z zeros are at infinity, and if zeros are greater than poles, z minus p poles are at infinity. So and one of the important point is, by adding pole, order of the system increases, then stability reduces, and root locus shift towards the imaginary axis. Which of the following points is not on root locus of a system with the given open loop transfer function? Here open loop transfer function is given as k by s into s plus 1 s plus 3, and 4 options are given. So this problem can be solved by option elimination method. Now keep s is equals to minus j root 3. By keeping s is equals to minus j root 3, you will get angle as minus 90 degrees minus tan inverse root 3 and minus tan inverse root 3 by root 3. So you will get total overall angle as 180 degrees. And for any point to lie on the root locus, it must satisfy the angle criteria. The angle criteria is nothing but angle of open loop transfer function g of s h of s must be odd multiple of 180 degrees. Here in this problem you have got answer 180 degrees. If you multiply 180 degrees with an odd number 1, you will get it as 180 degrees. So by this we can say that s is equals to minus j root 3 lies on the root locus. In this option, s is equals to minus 1.5, which does not lie on the root locus, and remaining all points a, c, d all will lie on the root locus. But from this problem you can find out for any problem what is the condition for a point to lie on root locus. It must be an odd multiple of 180 degrees. In this problem, the final answer is s is equals to minus 1.5. The method for determination of stability of the feedback system as a function of an adjustable gain parameter which does not provide detailed information concerning location of closed loop poles as a function of gain k is called root locus method. So root locus method gives the information about the stability of a feedback system as gain parameter. It gives the information about the stability of a system, but it does not provide detailed depth information where the location of the poles are there and where they are located. It does not give the detailed information about the closed loop poles, but it gives the information about the stability. So root locus method is the method which gives the information about the stability of a feedback system. Consider the following statement related to root locus. The number of branches of root locus equals the number of closed loop poles. So in root locus, each branch represents one closed loop pole. But to find the root locus, we use only open loop transfer function. But each branch in the root locus represents closed loop poles. While drawing the root locus, if you want to map the poles and zeros, we use open loop poles and open loop zeros, but each branch in root locus represents closed loop poles. The root locus is symmetrical about real axis. Yes, right. The root locus approaches straight lines as asymptotes as locus approaches infinite. As k tends to infinite, branches becomes asymptotes. So both 1, 2, 3 are right. Which one of the following statement is correct regarding root locus technique? Root locus technique, it can be used to analyze and design the effect of loop gain upon the system's transient response and stability. That is the right option. Transient response can be defined by eta and omega n, and stability can be defined by observing whether root locus belongs to the right half plane or left half plane. So root locus gives information regarding the stability and transient response. In this problem he is asking to find the phase angle of the system. Here g of s is given as s plus 5 by s square plus 4s plus 9, which varies between. So here angle can be defined as head and tail. Head represents when omega tends to infinity and tail represents when omega tends to 0. To find the tail, there is a direct formula you can use to find a tail is equals to minus 90 into type of the system. To find the head angle, you can use the formula minus 90 into p minus z. Here, now convert this g of s into g of j omega. Now write omega is equals to 0, means he is talking about the tail of the system. As omega tends to 0, magnitude will be 5 by 9 and angle will be minus 90 into type of the system. In the G of S, the type is 0. So minus 90 into 0, you will get it as 0. And to find the angle of the head when omega tends to infinity, formula is minus 90 into P minus Z, or you can write 90 into Z minus P. You will get angle of head as minus 90 degrees. So from this problem, there is a conclusion that when omega tends to 0, you will find the tail, and when omega tends to infinity, you will find the head. To find the tail, you will use the formula minus 90 into type of the system, and to find the head of the system, you will use the formula minus 90 into P minus Z, or 90 into Z minus P. The Nyquist plot of servo system is shown in the figure. The root loci for the system should be. See, in this, the head is minus 180 degrees and the tail is minus 90 degrees. You know, head formula is minus 90 into P minus Z is equals to minus 180 degrees. By calculating P minus Z is equals to 2, and if Z is equals to 0, you will get poles as 2, and here tail is minus 90 degrees into type, so type will be 1. So from this you can say that the type is 1 and the order is 2. So from the given question, you have two poles. One pole is at origin, that's why it is known as type 1, and another pole is at somewhere in the left half of S plane, that's why you can say it is order 2, and root locus flows between these two poles, and option B is the right option.